I'm Alex.
I'm Mike.
I'm Sam.
I'm Ethan.
And we are the Wolfpack Music Makers.
Our project is the Mechanical Music Maker.
Our first milestone included problem identification, working criteria, and research. The problem that we will be solving is building a mechanical music maker. The criteria that we have to follow is that our mechanical music maker has to be 50% mechanical, battery operated, or hand operated, fit within a 3 foot by 3 foot by 3 foot cube, and play a duration of 10 seconds to 1 minute of music. Our mechanical music maker will be evaluated based on creativity, originality, design, construction quality, and music quality. Based on the research that we conducted, we found that mechanical music makers started out in Switzerland in the 1770s. They were small enough to even fit inside a pocket watch. The musical box contained a number of steel teeth that were plucked by pins on a brass cylinder. This plucking created a vibration which subsequently produced musical notes. Over time, numerous different mechanisms have been used to produce sound from the music box. Later on, in the 1900s, all of these innovations eventually led to Thomas Edison in his invention of the phonograph. Once the phonograph was produced, the music box was basically phased out.
For milestone 2, we had to come up with 10 ideas for a mechanical music maker. So the first idea was that we would have guitar strings plucked by the metal fingers of the machine, and the notes would be determined by a rotating disc or cylinder or sheet, whichever we wanted to use, and it could be electric or hand powered. The second idea was to have a box with metal teeth that plucks the teeth by a revolving mechanism, a cylinder, in the center with small pins sticking out. As the cylinder revolved, the pins would hit the metal teeth that they were in line with. Our third idea was a box with whistles and stretchable tubing. Airflow would be attached to one end, and a crank mechanism would extend the face of the box to adjust the pitch. Our fourth idea was a hand crank that powers a mechanical music maker, which allows the wheel or cylinder to rotate. This wheel or cylinder will determine the notes played on any instrument picked. Our fifth idea was an instrument that was powered via channeled airflow. A crank mechanism would move the flow left or right, and a slide mechanism would change the volume. Air would be moved by either a fan or pump, and the harmonica would be the instrument that we used to create sound. For our sixth idea, we would have a glockenspiel that is struck by hammers or mallets to produce music, and the mallets or hammers will be determined by a rotating cylinder that is powered by hand or battery. Our seventh idea was Arduino that uses timed switches to move various other parts of the structure. Specifically, at a given time, the Arduino is programmed to flip certain switches, which causes the mallets to strike a glockenspiel or steel drum. For our eighth idea, we thought about having a D-shaped mechanism, and there would be a rotating belt at the bottom which moves the crank mechanism, and then that would cause mallets to strike a drum or a glockenspiel. For our ninth idea, we thought about having a robot play a saxophone, and it would mechanically press keys and notes determined by a rotating cylinder. It would be powered by hand, and an air pump would be powered by battery. And then finally, for our 10th idea, we would have a pre-made mechanical music maker adjusted to take electrical current, which causes the triggering of different areas of the larger instrument in a particular sequence.
Milestone 3 is broken up into 3 parts. The first part of Milestone 3 is to analyze each of the Milestone 2 potential ideas, as well as including criteria for them, but due to time constraints, I'll only be going over 6. The first idea from Milestone 2 was the implementation of guitar strings. We decided to accept this idea because it was practical by our standards, but we would need something to power the disc, cylinder, or sheet, which was talked about in the next ideas. The next idea that I'll be discussing is idea number 3, which included the box with whistles and stretchable tubing. We decided to reject this idea because it seemed terribly difficult to build and perfect with a $40 budget in less than half a semester. Some of the difficulties include controlling airflow mechanically, and it would be extremely hard. The next idea I'll be talking about is idea number 5. Idea number 5 was the use of an instrument which will be channeled by airflow. We decided to reject this idea because this method is comparatively complicated. It has a lot of moving parts, and at the same time it requires a lot of time to build. As far as budget goes, there's a high likelihood that even the raw materials will go over our initial budget of $40. Also, the mechanics will require precision for smooth movement and easy changes. The final product could be luxury class, but is not practical as the complexity and costs make it hard to complete. Idea number 6 is the next one that I'll be discussing. Idea number 6 included the implementation of a glockenspiel. We decided to accept this idea because this method is extremely practical due to the fact that we have already obtained a glockenspiel and the rest of the materials are easy to procure, as it would involve wood and string, and depending on the type, it would be very cheap. Calibration could also take time, but it would be easy to do. The next idea I'll be talking about is idea number 7, which uses an Arduino. We decided to reject this idea because we probably cannot use it due to the nature of the mechanical music maker box and the time constraints of building the box itself. We need it to be at least 50% mechanical, and this would be taking way away from the total for our project. The time to program, install, and test this idea would be massive, and we would have to complete the project within our allotted time, so we just thought that we cannot do this. Finally, I will be discussing idea number 9, which is robotically playing a saxophone. We also decided to reject this idea because finding a robot that could play a saxophone is highly complex and difficult, and it would definitely exceed our $40 budget as well as our limited materials. Also, the robot would most likely not fit into the 3x3 box. The second part of Milestone 3 is to discuss the potential ideas that we are thinking about using in our initial design. Of these ideas, we want to include the glockenspiel hit by mallets. We want the notes to be determined by a disc or cylinder that is rotated due to either electrical or hand cranking.
For milestone 4, we had to finalize our design. We decided to go with the glockenspiel idea as we had already obtained it. For our preliminary modeling, we used Legos to better figure out our programming for our design. The basic premises of our design is to have our glockenspiel struck by a series of mallets in a particular order designated by a rotating cylinder, which is turned by a hand crank.
For milestone 5, we had to determine the percentage of our Fed project that was complete. We determined that our prototype was 95% complete at the time of milestone 5. In order to determine that, we had to give objective evidence, including pictures and text. In order to provide that evidence, we showed that our frame was built, the glockenspiel was secured to the frame, the cylinder was secured and programmed correctly, the mallets and the fulcrum mechanism were installed and operate correctly, and the gears to rotate the cylinder were built and installed. We also had to determine how close our prototype matched the final design that was given in milestone 4. We determined that it was 85% matching the final design from milestone 4. We determined this because the 3D printed mallets from the final design are now wooden with metal hex nuts on the end. We did this because the price of filament would have exceeded our budget, and PLA filament would not have resonated correctly with the glockenspiel. The other thing that we changed is that the wooden cylinder with Legos is now a PVC pipe with screws. The price of Legos would have exceeded our budget, and the Legos would have not stayed in place in order to determine the mallets, and it would have been difficult to build a cylinder out of wood and stay in our budget.
Here we are at Freshman Engineering Design Day. We got Alex, Sam, Michael, and myself. And here's our project. So let's give this a test run, see how it goes.
Like they were